Welcome. Let's look at Lecture 17 and we're going to do some graphing. We have a series of steps that we follow in graphing. Factor numerator and denominator to find the domain. Reduce the fraction to find the vertical asymptote. Any holes in the function? Horizontal asymptotes? Does the graph cross? Intercepts? Symmetry if there is one. And then we set up a number line. We use the zeros of the numerator and denominator, so those would be the holes and the asymptotes and the intercepts, and divide it into intervals. And then we decide if it lies above or below. We sketch the asymptotes and plot the points and graph the function. So you can read these, you can copy that out if you want to, and as you're doing problems. Let's begin with the example on page 7. We've covered the example on page 8. So we'll do this example, and then we will do page 9 and 10 as well. Okay, and this camera does not want to focus, so it seems to have its own mind tonight. So let's see if we can get it to focus so that we can show you what's going on. Okay, let's see what we can do here. Now what I'm going to do, if I can ever get this working, is to start over here on this page with some basic stuff. Let's get it. Let's see that we're hitting the right spot here. There. Okay. Finally. Let's see if we can figure out what this is doing. Okay, so the first thing I want to do is start with this, and I want to start by actually factoring that. Okay, so that's what, 2x and x, and it looks like I'll need 4 here. Okay, so it's got to be 1, and I want plus 7, so it's going to look like this. And our denominator factors is x plus 2, x minus 1. Now the first thing you want to always do is double check your factoring, because if it's wrong, everything's wrong. Okay, so make sure that's right. And now we'll just go down our list. We're going to look at the domain, and we see that x can't be negative 2 or 1. So this domain I'll actually write in interval notation. Okay, and then as soon as I have that, the next thing I like to determine are the vertical asymptotes. Now where do we find the vertical asymptotes? They're where the denominator equals 0 and the numerator is not 0. And if we see there's no common factors in numerator and denominator, so the vertical asymptote will be both of those. And notice vertical asymptotes are lines, not just numbers. So make sure you represent them as lines, especially in WebAssign. It doesn't like it if you just put in numbers. Okay, how about holes in the function? Well, remember, holes occur when there's a common factor that reduces, and we don't have that situation here. Okay? Now the next thing we're going to look at are the horizontal asymptotes. I should say horizontal asymptote. There's either none or one, at least in this type of function. So let's see. What do we look at for the horizontal asymptote? Remember that we want to look at the unfactored form because we want to look at just the highest degree terms. And notice that they have the same degree. So if I think of reducing that fraction, it's just the coefficient y equals 2. So our horizontal asymptote is y equals 2. Okay? Now the next question we want to ask ourselves is, does the graph cross the horizontal asymptote? Okay? And remember how we determine that. The horizontal asymptote is y equals 2. So if it's going to cross, there is some x so that the function value y would be 2. So that's the equation we solve. We simply set the function equal to the horizontal asymptote. And we'll go back again to the unfactored form. X squared plus x minus 2. And we set that equal to 2. And how do we solve that equation? We simply clear fractions. And we get the following. Okay? And so we multiply through. Okay? And notice what happens in this case. The x squareds cancel, and the 4's cancel. And we're left with 7x equals 2x, or I can rewrite that as 5x equals 0. And that only happens when x equals 0. So does this cross? Yes, when x is 0. So that means it's going to cross at the point x being 0, and f of x is 2. So it crosses at that point, and that point is actually the y-intercept. So that's the next step, the y-intercept. You take f of 0. And if we go back to the original function, you get 2 times 0 squared plus 7 times 0 minus 4 over 0 squared plus 0 minus 2. And sure enough, you get f of 0 is 2. So the y-intercept is y equals 2, or the point 0, 2. X-intercepts, that is the zeros. It's where the numerator is equal to 0, but the denominator's not. And so we set the numerator equal to 0 because we want to set f of x equal to 0, which means just the top is equal to 0. Actually, the whole thing is equal to 0, but we're just looking at the numerator. Notice I'm back to the factored form again. There are no common factors, so that will not be an issue here. So it looks like x equals 1/2, or x equals -4. And again, that translates into points on the graph. Okay? Now, the next thing we want to ask ourselves is symmetry. And I'm going to let you check it out. Symmetry, remember, depends on what happens when you take f of minus x. And in this case, it's not equal to f of x. So it's not symmetric around the y-axis. And it's not equal to the opposite of f of x. So it's not symmetric around the origin either. Okay. So now what do? Now we've done a lot of the basics. So we go back now, and what we want to do is take all of this information and put it on a number line. Okay, let's try focusing again. Okay. So what information do we put on a number line? What do we know? Well, we put in, first of all, the vertical asymptotes. And I like to put slashes through them. That just reminds me when I'm graphing that those are asymptotes, not points on the graph. We also look at the zeros. Notice we're looking at the x values only. So the zeros were at 1/2 and -4. Okay, so those are the zeros. Okay, so that's what's going to be in our number line, just those values. All right, so now we'll set up our number line. And what we observe is that we now have several intervals, up to -4, between -4 and -2, -2.5, 1/2 and 1, and those values greater than 1. We're looking at the x values only. And the question that we're trying to answer is, does it lie above or below x-axis? That's the question we're going to be asking ourselves. That'll help us graph. So how did we do it? Remember, in the past we take trial points. So let's use -5, -3, 0. Always use 0 if we can. Ooh, here we'll have to use 3/4, and let's use 2. Okay? Now what do we do with those trial points? We want to find function values. So now let me go back to the other page so we have a little more room, and let's go ahead and find those function values. So -5. Now remember, f of x is the product. 2x minus 1, x plus 4, x plus 2, x minus 1. Okay? And so what's f of x? I just plug that in. So it's 2 times -5 minus 1, -5 plus 4, -5 plus 2, -5 minus 1. So that is what? -11 times -1 times -3 times -6. Notice that I have an even number of negative signs, so that becomes positive 11 over 18. Okay? So that's the function value at -5. All right, go back to my number line. What was the next one? Oh yeah, -3. Okay? Same thing. 2 times -3 minus 1, -3 plus 4, -3 minus 2, or -3 plus 2, sorry, -3 minus 1. It's very tedious, but it's a pretty straightforward process. So it's -7 times 1 over -1 times -4. This time I have an odd number of negative signs, so it's -7/4. Okay? And our next value was what happens at 0, and we've already seen that f of 0 is 2, so I won't go through that calculation again. 3/4, okay. It's a mess, but still not doable. It's 2 times 3/4 minus 1, 3/4 plus 4, 3/4 plus 2, 3/4 minus 1. And that's equal to what? 3/2 minus 1, so that's 1/2. And 4 times 4 is 16/4 plus 3, so it's 19 over 4. And 4 times 2 is 8, so that's 8/4 plus 3/4 is 11/4. And it looks like we have 3/4 minus 4/4, so it's -1/4. Okay, so I have 19 over 8 over -11 over 16. If you flip that around and do the arithmetic, you get -38 over 11. Okay, that's what happens at 3/4. Let's see, do we have any other value? Oh yeah, 2. F of 2 will be 2 times 2 minus 1, 2 plus 4, 2 plus 2, and 2 minus 1, which is what? 3 times 6 over 4 times 1, which is 18 over 4, or 9/2. Okay? So it's just a question of getting those function values. All right, now I go back and I translate that to what it means for us in terms of our number line. Okay, so we'll go point by point. Notice that f of -5 was 11/18. That is positive, so that means the graph lies above the x-axis. Everywhere up to -4. Okay? Between -4 and -2, we had a function value at -3 of -7/4. And so it's negative, it's going to jump below. Okay, we cross over the asymptote at -2. at 0 rather, our function value was 2, so it lies above. At 3/4, our function value was negative 38/11. It's going to go below again. And on the other side of the asymptote, at 2, we had the value of 9/2, so it lies above. Okay, do you see the process? First of all, I look at the asymptotes and the zeros of the function to separate my number line into intervals. Okay, then I take a trial point on each interval and use its sign to determine what's happening to the graph, whether it's above or below the x-axis. Now, on the exam, you're not going to have one with quite as many intervals, but we want you to see the process. Okay, now we have all the information that we need to graph. Okay, so how do I graph? I begin by putting in my asymptotes, my vertical asymptote at -2, and at 1, my horizontal asymptote, if I go back to my notes, horizontal asymptote was y equals 2. Okay, and now we plot our points. Remember, we had the y-intercept was at 0, 2. And then we had our x-intercepts, which are the zeros that we've already been looking at, -4 and 1/2. So those are the intercepts and the asymptotes. Okay, now we plug in the actual points. We've gone to all that work. Let's go ahead and get a rough idea of what's happening there. Okay, focus that one more time. All right, so at -5, which is right here, we are just slightly above 11/18 is less than 1, so it's right about here. Okay, at -3, we're down at -7/4, which is a little bit less than, let's see, 8/4 would be 2, so it's a little bit less than -2. Okay, and then at 0, we're at 2, we already have that point. At 3/4, which is squeezed right in here, we're down at -38/11, which is actually a little bit lower than -3, because 33/11 would be 3. So it's a little bit lower than 3. Okay? And then finally, at 2, we jump up again. 9/2 is what? That's 4.5. 1, 2, 3, 4.5. So we've got our points, we've got our number line, and we have our asymptotes, which are really going to give us an idea of the behavior. And remember, it only crosses at that point, so it's not going to cross anywhere else. So if I look at this, all right, and let's expand our axes so we can get an idea here. All right, what's happening? Well, we know that it lies above the axis all the way up to this point. Okay, we have a horizontal asymptote, which means it gets closer and closer to that value, but doesn't quite get there. That's our end behavior, so our graph is going to look something like that. Then it dips below. We have a vertical asymptote, and we know that the graph gets closer and closer, but does not touch at the vertical asymptote. Okay, what happens between -2 and all the way up to 1/2? It lies above. It never crosses the horizontal asymptote again, and the vertical asymptote behavior must indicate that it's looking like this. It has to, because the only two choices I have for the vertical asymptote is it's either doing this or it's coming up like this, but if it's coming up like that, it's not above the axis. That's where that information is really useful, that it lies above all the way up to, and in fact all the way up to this point, 1/2. So it's got to kind of fit in there. And then it goes below, and there's an asymptote, So we expect the graph to be doing something like that. Okay? What happens if x is greater than 1? We see that it lies above the axis. Again, we have our asymptotes directing what that graph is going to look like. The graph never touches the horizontal asymptote after that point 0.02, so we know with confidence that it's got to be coming down and looking like that. So that's the graph of that function. This is a really good example. It shows quite a bit of details. Please don't be intimidated. You just go a piece at a time. You get your asymptotes, your vertical asymptotes and your zeros to set up your number line. You plug it into the function and you get your graph. Okay, thank you very much, and we have videos of the other graphs as well.